recording. And you can minimize that panel if you want.
Okay.
If you click on the orange rectangle with the white arrow in it, it's a toggle switch. It minimizes it and maximizes it.
Okay.
Okay, and when you minimize it, you can kind of move it out of the way so it doesn't cause you any difficulties. Okay, let's see. You're taking Algebra 2, is that right?
Algebra 1.
Algebra 1, okay. Let me change my notes here. So, and you go to Chatfield, right? You're a freshman.
I do.
You're a freshman at Chatfield, okay. Do you have any specific problems that we can go over? Let me show you how this works. I have a drawing tablet here. And whatever problems we want to go over, let's say you had an equation you want to solve. 3x plus 2 equals 8. How would you solve it?
How would you solve it?
Yeah.
Subtract 2 from both the 8 and the 2.
Now what?
And you divide by 3. So x is equal to 2.
Okay. That's essentially the way it works. Now, I usually ask the students to bring all of the problems to the session. In other words, algebra is a big subject, and I really don't know exactly what you've covered in your class at the moment, so I need you to direct. And either you can verbalize problems, and I'll write them like this, or you can take a picture with your phone of a sheet of paper that has a bunch of problems on them and send them to my email address, and then I'll bring it up on my screen, and we'll both be looking at it.
Okay.
And my students do, half a dozen of one, 6 of the other. Half of them will verbalize their problems, and half of them will take pictures and send them to me. Some problems can be difficult to verbalize. If they give you a graph and they say, okay, write the equation of that graph, well, it's hard to verbalize a graph. So that's a kind of problem that I would need to be looking at the graph. So do you have any specific problems tonight that you'd like to verbalize?
A couple, yeah.
Okay, let's go through them. It'll give me more an idea of where you're at in Algebra 1.
Okay, well, the sheet I was working on was writing equations in slope-intercept form.
Okay, what's slope-intercept form? What's the general?
Isn't it like the equation, like the basic equation, right?
That's slope-intercept form right there.
Okay.
Y equal mx plus b. Remember that because you're going to be using it a lot. That is the standard format of a line. Where m is what?
M is your, it's a slope.
And b is what? Y-intercept. Okay? That's why it's called slope-intercept form, is because we have a slope and we have a y-intercept.
Okay.
Okay? So if I had an equation that was y equal 2x plus 1, how would I graph that?
Okay, so why don't you put in a 0 for x?
Yeah, although since the equation is in slope-intercept form, I already know that point right there is the y-intercept.
Right.
So I could start by going to 1, and you're right, that means x is 0 also, but there's one point on my curve. 2 points make a line, so the only thing I need is one more point. How do I get it?
Why don't you,
Slope means what? Verbally.
Isn't it when you use rise over run?
That's what you want to know. Rise over run. So in our case, the slope is what?
It's 1, 0.
It's 2. It's
1 over 0.
It's m.
Or so 1.
Well, this point is 0, comma 1.
Right.
But I need another point. Well, in order to get another point, I'm going to use slope. It means I have to start from my first point the y-intercept, I'm going to go up 2 and to the right 1. There's my other point right there. In other words, that point has a slope of 2 on it because I went up 2 and to the right 1.
Okay.
Okay, and that's what you do, is you start with the y-intercept and then you use the slope. If that slope would have been 3, I would have gone up 3 and over 1. If that slope would have been 3/2, I would have gone up 3 and over 2. So slope-intercept is the standard form, and once you know the slope and the intercept, you can graph it.
Okay.
Okay. So specifically, what kind of problems?
Well,
You have a specific problem?
Well, yeah, it's kind of fill in the blank. It's
That's fine.
y equals -2/3, and then it on the bottom because it's a slope and it says through. And
what's the rest of the equation? Is it just y equal -2/3? Is that it?
Well, that's all I have for now, because
Well,
we're supposed to be taking the slope. They give us like a slope. They give us pieces.
hold on a second. If that's your equation, that's a unique line. That is a horizontal line. Has a slope of 0. I go down to 2/3. There's -2/3. And it's just a horizontal line. I draw straight through that.
Okay.
That's y equals -2/3. Now, notice I said the slope was 0. All horizontal lines have a 0 slope. So there is no mx. In other words, if m is 0, then that whole term disappears. So the only thing you end up with is y equal b. So the y-intercept is -2/3. Okay?
Okay.
What else you got?
Well, there's this other one, and it's y equals blank x. And then we don't have the b, so we have to fill in the m and the b. And it gives us 2 coordinates. It gives us 9 and 10 and 8 and 13.
All right. Let's start with the 2 coordinates.
Okay.
What do we need in order to solve for this? We need m and we need b.
Yeah.
Okay? M is what? Slope.
That's a slope.
But it's rise over run, so how are we going to get it from these 2 points?
Don't we have to make like?
There's the rise right there. The second y-coordinate minus the first y-coordinate.
Okay.
Here's the run. The second x-coordinate minus the first x-coordinate.
Okay.
So what number does that convert to?
Wouldn't it be y1 and then x, y and x?
Well, what's y sub 2? What's y sub 2 in our 2 points?
2y?
No?
Oh, no. Oh, in our,
Yeah, it's this point right here. This is y sub 1.
Okay.
Y sub 2. This is x sub 1. And this is x sub 2.
Okay.
So what's y sub 2 minus y sub 1?
Was that 4?
13 minus 10?
Oh, my bad. I'm sorry. 3.
Okay, and what's x sub 2 minus x sub 1?
-1.
Okay, so what's my slope?
3 over -1.
That's the same as -3.
Oh,
Always simplify. Okay?
okay.
Okay, so we got our slope. Now the key is how do we solve for b? Well, it's actually pretty easy. Once you know the slope, I can begin to write part of the equation. Well, I know that y equals -3 was m plus b. Okay? Now, I can pick either of these points, plug them in for x and y, and solve for b. So let's do it. Pick the easiest point to work with, that one.
Okay.
What should I write?
Okay, so wouldn't it be 10 then instead of y? and then equals negative 3x plus 9.
Not negative 3x, negative 3 times 9. In other words,
9, okay,
I'm going to plug in that x value for x, and I'm going to plug in the y value for y, and now I can calculate b. What is b going to be?
So, okay, sorry.
What's minus 3 times 9?
Minus 3 times 9, is that negative 27?
Yeah, so I'm going to replace that with negative 27. Now what?
Would you add 27 to that and add 27 to 10?
Which makes b equal 37.
Okay.
Now I've got m and b. So I'm ready to write my equation. What is it? I'll write it down here where we can see it a little better.
Okay.
What was m again?
M was negative 3.
Okay, so my final equation is what?
Y equals negative 3x plus 37.
You got it. That's how you do slope-intercept form when they give you 2 points. Is the first thing you do is you figure out the slope, and then you substitute one of the points into that much of the equation. And that allows you to always solve for b. Because notice, once I get slope filled in, I have 3 variables here. I have a y, I have an x, and I have a b. So if I can substitute for 2 of the variables, I can solve for the third one. And that's exactly what we did. Okay? Got another problem? They can give these to you in a variety of ways. They can give you 2 points. They can give you slope and 1 point. They can give you slope and y-intercept. There's lots of variations of this same problem.
Right. No more specific problems, I don't think.
Well, let me make some up. I've been doing enough of these that I can make these up pretty easily. So let's say we have a slope of 2, and we have a point of 2 comma 3. Let's come up with the equation of that line.
Okay, so we know that m is 2, so we know that y equals 2x plus b.
Okay.
And then when we use that equation, is it y2 minus y1?
No. We already got slope. We don't need slope.
We need b.
We need b.
So then we take in our equation, and y would be 3.
Okay.
And equals, and then it would be 2 times 2.
Okay.
Plus b.
Okay.
And then you multiply 2 times 2 is 4.
Okay.
And then you'd subtract 4, right?
So b is minus 1. What's our final equation?
Negative 1.
No, what's our final equation?
Oh, I'm sorry, my bad. Y equals 2x plus negative 1.
Minus 1. Always combine your plus minus there.
Okay.
Okay? When you plus a minus, it's the same as just minus.
Right.
Okay? So that we had a slope and 1 point. Okay? Now let me make another one where I will give you 2 points. It's the equation of that line.
Okay, so wouldn't it be x1, y1, and then x2?
Okay, hold on. Let's start out by saying we're going to calculate the slope.
Okay.
What's the slope going to be? It's rise over run. Start from that, and then convert that into your y's and your x's. Which one goes on top?
I want to be the 2?
The y's, right?
I'm sorry
In other
about
words, rise is related to the y coordinate. the difference in the y-coordinates. So the difference in the y-coordinates is that. What's the run?
x2 minus x1.
Okay, and then let's fill in some numbers. What's y2 minus y1?
It would be, wait, so, or like, are we doing like, wouldn't that be 2? Or no?
Well, it's
No.
3 minus a minus 1.
Okay.
That's y2 minus y1. And x2 is this 3 minus that 2. Now what is 3 minus a minus 1?
3 minus a minus 1 would be a positive, or no.
Yep.
Yeah, be a positive 2. Or
Positive 4. It's the same as 3 plus 1. In other words,
okay.
These two minuses turn into a single plus.
Okay.
So it becomes 3 plus 1, which is 4 over 1. So our slope is 4.
Okay.
Okay? Now we have a slope and 2 points. So we can pick one of those points and do the rest of it. But
okay.
How much do I know so far?
We know that this m equals 4.
M equals 4x plus b. That's what we know so far, because we figured out the slope was 4.
Okay.
So now how do we get the b?
We take one of our points.
Okay, pick one of them. I don't care which.
The 3, 3.
Okay, so what's the equation I'm going to write?
Wouldn't it be y, or no, sorry, 3 equals 4 times 3 plus b.
Okay. Simplify that.
Okay, so 4 times 3 is 12.
Okay.
And then 12 minus 3.
It's not 12 minus 3. It's 3 minus 12.
Okay, 3 minus 12, which is 9.
Negative 9.
Negative 9, I'm sorry.
Whenever you subtract a bigger number from a smaller number, you're always going to get a negative. So what's our final equation?
We're going to have y equals 4x plus negative 9.
4x minus 9.
Or minus 9, I'm sorry.
That's okay. I'll keep reminding you every time you do it, and it'll... Okay, so we did one where we had slope and 1 point. We did this one where we had just 2 points, no slope. We had to figure out the slope. There is one more way they will present it to you. That is, they'll give you slope and y-intercept. What's the equation of that line?
Y equals negative 3x plus 5.
Yeah, we wish they always gave it to us like that.
Yeah.
That's the only 3 ways I can think of that they would mix it up. In other words, I've just been looking at tests that have these kind of problems on them. In fact, I can even pull one up here and show it to you for sample problems. Let's see. Got all these problems here. Let me open one of those files. Yeah. Notice question 10. Write the equation in slope-intercept format. The first problem, they gave you a slope and a point. We can do that, right?
Yeah.
Second problem, they gave you a slope and a y-intercept. We can do that.
Yes.
Third problem, they gave us 2 points. We can now do that, right?
Right.
Let's do the fourth problem on there. In
Okay.
the last 4 minutes here. I don't know if your mom told you, but my first session is just a half-hour session, and it's free. It's just kind of a demonstration of how it works. Okay.
Okay.
So they're saying that they want the equation of the line that is parallel to this line. They don't want the equation of this line right here. They're giving us this line. They're saying there is another line that's parallel to this line and goes through the point 1, 1. Well, the fact that it's parallel to this line tells me what?
That it's right next to it.
Means the slope is the same.
Oh, okay.
That's what parallel means, is the slopes are the same. So they basically told me, okay, you have a slope of 3 and a point of 1, 1. We know how to do that, right?
Yes.
Okay. The only other way they might do it is they might say, give me the equation of a line that is perpendicular to this line and goes through this point. Well, the line they're talking about would have a slope of what? If it's perpendicular, what's the perpendicular line slope equal to?
Would it be when it perpendicular? That's when it cuts through. So
the negative reciprocal. Okay, the negative reciprocal of 3. Well, that's the reciprocal. The negative. So the negative reciprocal of 3 is negative 1/3.
okay.
So that's the slope of the line we're dealing with. The line that's perpendicular to this is going to have a slope of negative 1/3. Well, that's okay. Now we got a slope and 1 point. We can come up with that equation. So there's actually 5 different types of ways they can give it to you. I forgot about the parallel and perpendicular. So now we know how to do 5 different problems, all coming up with the slope-intercept format.
Okay.
That's kind of the way this works. Incidentally, this page we're looking at here was, the guy just took a picture with his cell phone camera and sent it to my email address. Not my phone, but my email address, and that way I was able to bring it straight up on my computer, and we were able to work from that page.
Okay.
So you might prefer to do that if we have a future session.
Okay.
And my email address is on my website, so your mom can probably find it easy enough. Let's see. Connor, you're looking at my schedule here.
Okay.
And you can see that you're right here in this slot. And if you want to schedule your next session, I can do it now for you, or you can go to my website and schedule it automatically.
Okay.
You might want to chat with your mom. Is she handy there? Is she close by?
Yeah.
Would you ask her what she would like?
You may put her on? Or?
Yeah.
Okay, here she is.
Kate?
Hi.
Hi.
How'd we do?
He did fine. I think he'll be happy with the online tutoring. I was just asking him if he would like to schedule another session while I have him.
Okay.
And what you're looking at here is the rest of my week. So
Okay.
tomorrow probably isn't a good day. I have some slots available on Thursday and a whole bunch on Friday and Saturday and Sunday.
Got it. I would like to schedule something, but I need to see, because we co-parent, and Thursday and Friday,
Okay.
he is with his dad.
Okay.
So what I might do, if it's okay with you, I can do the scheduling online, right?
Yes. And I
Okay.
don't know if have you been to my website? Did you go to Algebra to Calculus Tutor, or did you go to Digital Math Tutor?
Both, at your recommendation. I had started at Algebra to Calculus, and then you directed me to Digital Math Tutor, and I had saved it on my favorite.
Yeah, digital's probably the easier one, both to schedule and to pay.
Perfect. That's what you said.
Yeah,
Okay.
the PayPal on Digital Math Tutor is a little smoother than it is on the Algebra to Calculus. So that's why I generally tell people to use it. It's a little
Perfect.
simpler, and the scheduling is exactly the same. In other words, when you go to schedule, it just says scheduling for Dave Cowan. and
Perfect.
it'll show you my availability, and you can go ahead and make the session online.
Oh, wonderful. Thank you so much. And I will talk with his dad, and we'll get something on the calendar.
Sounds